Okay, so here we go with 10.1 notes. Quick reminder, I'm at the district office today, unfortunately, so I'm not able to be there with you. But if you have any questions over this stuff, feel free to send me an email through School Loop, and I will get back to you as soon as possible. Before I go much further, I want to let you know that the Mod 10 quiz has been moved to Friday. Now, keep in mind, even though it's called a quiz, it goes in the same points category as your tests do. So it could be a 30 to 35 point quiz, and that's pretty significant. It's kind of like a mini test, kind of like a group test. So make sure you take that seriously. 10.1 is the last new stuff that will be on the quiz. Tomorrow we're going to do a review for the quiz, and Thursday we'll have some time to go over that before you have to take your quiz on Friday. Okay? All right, so inverses of nonlinear functions. This is just like what we did yesterday. It's just that yesterday we did linear functions. We're going to follow the same set of steps, though, that we used for our nonlinear functions. Now, the steps are actually written a little bit different here. We did these in opposite order yesterday, so I'm probably going to follow that order. So let's see. In our first example, our original graph, or our original function, is f of x equals x to the third. So for f of x, we know that x to the third is our basic parent function cubic graph that looks like that. Our domain for that is all real numbers, as is our range. And we know that because all cubic functions have domain and range both of all real numbers. So, using our steps to find the inverse, the first thing I do is I take f of x and I replace it with y. So that gives me y equals x to the third. Then, I'm not going to do step 2, I'm actually going to do step 3. I need to solve for x. They say solve for y, but that's because they've already changed their x to a y. So I'm going to get x by itself. If x is to the third power, the only way I can get it by itself is to take a cube root. Cube root cancels out the cube. That means x equals the cube root of y. Now I'm going to go ahead and change my x and my y. Change all my y's to x's. Sorry, that's not your bell. That's the SSR bell ending while I'm making this video. Change all my x's to y's and my y's to x's. So there's my equation. Last step, change the y back to my new inverse notation. So f inverse of x is equal to the cube root of x. And that's my inverse. Now, excuse me, my inverse is a cube root. Now, if we remember our cube root functions, they also have a domain of all real numbers and a range of all real numbers. So this is what our graph looks like. It's kind of funky, the way they cross, but here would be our parent function, or the original one, and then the inverse, which is the cube root, is this guy right there. And when they cross, they kind of make this little figure 8 thing there in the middle. It's kind of neat the way it looks. Okay? All right, find the inverse of each function. Okay, and tell how you would have to limit the domains. I'm not going to really go into limiting the domain. Okay, so I have a square root function. The square root function happens to already be graphed on it. Keep in mind, graphing square root functions is on your quiz on Friday. We have a vertex at -2, 0, and we have our graph going that way. The domain of this graph, if I were to look at the graph down below, the domain is x is greater than or equal to h, which is -2, and my range is y is greater than or equal to k, which is 0. All right? Now I'm going to find the inverse of this. So the first thing I do is change my f of x to a y. And step 2, I need to get x by itself. Well, to get x by itself, I need to get x out of the square root sign. The way I get the square root sign to cancel out is I square it. So I have y squared is equal to x plus 2. Last thing I do, subtract 2. X equals y squared minus 2. And then I'm going to change my x's to y's and my y's to x's. So I have x squared minus 2 equals y. And finally, if we write the proper notation, our inverse of f of x is equal to x squared minus 2. Now, how do I graph x squared minus 2? Well, if I were to make my xy chart, my vertex is 0, negative 2. I want to find some values around there, negative 2 and 2. So let's see, negative 2 squared is 4, minus 2 is 2. Negative 1 squared is 1, minus 2 is negative 1. 1 squared is 1, minus 2 is negative 1. And 2 squared is 4, minus 2 is 2. So I just need to plot these points. Negative 2, 2. Negative 1, negative 1. 0, negative 2. 1, negative 1. And 2, 2. Now, this may look a little funky to you. Not just because I did a very poor job of drawing in my parabola. My parabola looks awful. I apologize for that. But it looks a little bit different because this one is a full parabola, whereas the square root was only half the parabola. So it doesn't quite match up to be an inverse. The only way it could actually be an inverse is if I cut off this half of the parabola, right? And that has to do with the fact that we talked about how a square root is only half a parabola. Well, the way you make it the full parabola is if you have the plus and the minus there. Since we only have the plus, we only have half. So when they talk about limiting the domain, they're saying make sure that you cut off this half of the parabola because it's really only this half that is the inverse to that radical right there. Okay? So if I'm leaving my inverse as the whole thing, because we're not going to talk about restricting the domain, we should be able to change this. Let's see, our domain here would be all real numbers, and our range would be y is greater than or equal to negative 2. If we restricted the domain, this is very simple. Remember how with inverses we just switched the domain and the range? Do you see how x is greater than or equal to negative 2? And now it's y is greater than or equal to negative 2. So if it was y is greater than or equal to 0, then the way we would restrict the domain is we would say x has to be greater than or equal to 0. That would cut off this whole half of the parabola, leaving it to start right there, and that's the exact inverse. Okay? So truthfully, I would accept either one. This one is a little bit trickier to come by unless you just take the original one and remember that you can reverse them. Okay? So if you want to be super smart and impress me, go ahead and put the x is greater than or equal to 0. Okay? All right. This one, we're starting off with a parabola. If you see the graph down here, what is the domain of that parabola? It is all real numbers. What is the range of that parabola? Well, that would be y is greater than or equal to 3. So let's go ahead and find our inverse. Change the g of x to a y. And now I'm going to get x squared by itself. So I'm going to start off by subtracting 3. So I have y minus 3 equals 1/2 x squared. And now to get rid of the x, to get rid of the 1/2, I have to multiply by 2. I have to multiply everything over here by 2. So that gives me 2y minus 6 equals x squared. And now I have to square root both sides. Now, remember when you square root both sides, you must put plus and minus. So the inverse is plus and minus 2y minus 6. And let's see, now I'm going to change my x's to y's and my y's to x's. So I have plus or minus the square root of 2x minus 6 equals y. And then finally, we write our proper notation. So g inverse of x is equal to positive and negative square root of 2x minus 6. That would be my inverse. Now that one's a little ugly to graph. But if I think about it, 3 on my y-axis is probably going to be 3 on my x-axis, would be the reflection. So let's just do a quick xy chart. If I started with 3, it's probably going to be going around like this. It's going to be arcing over towards the right. So let's do like 3, 4, and see what we get. So 2 times 3 is 6, minus 6 is 0. So we're good there. 2 times 4 is 8, minus 6 is 2. So I get plus or minus radical 2. That's hideous. Let's see, 5, that'd be 10. Let's do 5. That one's better. 2 times 5 is 10, minus 6 is 4, square root of 4 is 2, so I have positive and negative 2. So let's see, 3, 0, 5, 2, and 5, negative 2, and that's about all I'm going to be able to fit. So again, that one was kind of ugly. But what would my domain be there? I don't need to restrict anything because they are direct inverses, as long as you include the plus and minus. My domain here looks like x has to be greater than or equal to 3. Whoops, not y. X has to be greater than or equal to 3. And my range would be all real numbers. Again, should be exactly the opposite of what I had in the original. Domain becomes the range, range becomes the domain. So let's see, when we're talking about a linear equation, whenever you have a whole number as your a value, the inverse will most likely be a fraction. That's just the way it works. Restrictions on the original one must have a non-zero slope, meaning that the original one can't be horizontal. If the original one is horizontal, the inverse will not be a function. Okay? Square roots and quadratics are inverses. So if your original one is a squared or a quadratic, your inverse is going to be a square root. And vice versa. If your original is a square root, your inverse will be a quadratic. Don't forget to take your plus or minus when you have one like we just did. You must have that plus or minus there. Restriction of the domain, you may have to have non-negative values like we discussed there. But again, I'm not going to be grading on that. So cubic, cube roots, there's no restrictions. We don't need to worry about that. If you have a cubic, the inverse is a cube root, and vice versa. If you have a cube root, the inverse is a cubic. Okay? All right. So, starting with f of x. F of x is a parabola. It has a vertex of what? 0, negative 1. We've already got that written down. It's a parabola stretched vertically by 2, reflected vertically, and translated down 1. Okay, so she has our what do you call it? Our XY chart already there. If we were to graph this, negative 2, negative 9, negative 1, negative 3, 0, negative 1, we have something that's looking like that. So our domain would be all real numbers. Our range would be y is less than or equal to whatever that top point is at our vertex, which would be negative 1. Now, if we do this correctly, our domain and range for the inverse should be opposite. If our domain was all real numbers, our range should be all real numbers. And if our domain was y is less than or equal to negative 1, our range should be x is less than or equal to negative 1. Okay? So this one is a sleeping parabola, meaning it goes sideways, stretched horizontally as opposed to vertically by 2, reflected horizontally instead of vertically, and translated left 2. Okay, so let's find this. First thing I'm going to do is change f of x to y. And now I'm going to get x by itself. So I'm going to add 1. Y plus 1 equals negative 2x squared. I'm going to divide everything by negative 2. So I get negative 1/2 y minus 1/2 equals x squared. And now I need to square root. And when I square root, I need to remember plus and minus. By the way, do I need to remember plus or minus when I'm taking the cube root? And the answer is no. Cube root did not have that issue where you had two sides of something. Cube root was just a inverse just as it was. There was no issue with that. Only with the square roots and fourth roots, and you actually have to do it anytime you take an even root. But odd roots are fine. So cube roots, you do not need the plus or minus. Square roots, you do need the plus or minus. So let's see, plus or minus the square root of negative 1/2 y minus 1/2 equals x, because that will cancel. So now I'm going to switch my x's to y's and my y's to x's. X minus 1/2 equals y. and then I change it to my new notation. So f inverse of x is equal to the square root of negative 1/2 x minus 1/2. Okay? So I could graph that if I wanted to. My domain and range would be switched. She has an xy chart, so if I wanted to graph that, all I have to do is flip my x's and my y's. So negative 9, negative 3, negative 1, negative 3, negative 9, negative 2, negative 1, 0, 1, and 2. So if I think about the way that looks, negative 9, negative 2, negative 3, negative 1, negative 1, 0, negative 3, positive 1, and negative 9, positive 2. We've got something that looks like that. Okay, whereas the original one was like that. So there's our reflection. If we wanted to, we could graph those. And this one, because it's not in our, because it has a b value going on and it's not in our easy form, you couldn't see any of that, and it's not in our easy form to graph from, it would be easier to graph it using this than it would be to try and find h and k, because negative 1/2 is not h. There's a b value going on as soon as there's a letter number in front of your x, and it just kind of gets confusing. So this one, it actually is easier to just change the x and y columns to graph it. Okay? So your assignment is on page 404, numbers 1 through 3, 7 through 10, 12, 16, and 18. I will try to get that up on Google Classroom for you. If not, you're going to need to make sure that you open your textbook for that. Okay? Happy studying.